Today we'll be speaking about shipping and keeping it alive. So at some point we are all developers, so we have all done the ideation part, documentation and implementation. So that's called development. And now after that there's something called deployment. Deployment is where you put your code to the server. And after deployment, there is something called shipping. Shipping is where you make sure your product or whatever you are building works and does not fail in production. So I think you can see. So yeah. So we are going to talk about areas. Today we'll start with the operation events, which is the scope, and then we'll go to the 6 critical questions and baselines that each developer while shipping and building a product need to ask themselves. And then there is the failures, what fails when whatever you build is in production. Then there is the maintenance and the sizing. So what is operations? Operations is ensuring your system in production is working, it's alive and healthy. So the modern engineers do not just build, they run. The core idea here is building softwares and running software. These are two different skills. I talked about deployment first. Deployment is the easier thing, and then we have operations. So deployment is getting your code onto the server, and operations is that code will need to serve real people day after day. So this is where everyone may get challenges, and most outages and bugs appear here. So we have deployment versus operations. So we have two scenarios here. The first one is it deployed clean. We have two teams. One team, for example, you have been working on a feature for Z2 for the last maybe 2 weeks, and then on a Friday afternoon or evening, when it's time to deploy, you deploy and everything is clean, the deployment logs are clean, the CI pipeline is green, and that's a green light for everyone to go home and enjoy their weekend. But that Friday at midnight, 11:23 p.m., there was DNS failures which crashed and made some callbacks that were not alerted. That's one team. And then we have another team that says they have backup. They have backup, but they did not test their backups. This is like a driver who has a car and he always thinks he has a spare tire, and then he decides to go for a road trip somewhere, but he hasn't checked that tire for maybe 1 year. And then in the middle of nowhere out there, he gets a puncture. And then in his mind, because he believes he has a spare tire, he's safe. But when he checks it, it's also flat. So this tells you that backups are useless without tested restore processes. And also, clean deployment doesn't mean successful operation. Deployment is an afternoon work. Knowing when something is broken and recovering it is where the actual craft and where the discipline of the operation is needed. So next we have environmental phase shifts. There is development, staging, and production. So while you are developing a product, it's you alone and that product, or maybe local other developers. When that product fails, you can just go, because it's just there on your machine. When something in the database or anything else fails, you just go back and fix it there. So the latency is maybe 1 ms. It's just there on your computer. Here you use fake data. If it breaks, you just restart and move on. There's no consequences. And then we have the next stage, which is staging. This is where you have testers and a panel of people who test whatever you have built. Now when you fail here, it's embarrassing, but it is recoverable. And then we have production. This is where your product meets 100 of users and a real-time transaction, for example, Z2. Now when it fails in production, it will break, and going back will not be as easy as it was while you are developing it. Then we have latency, which is the difference between how your product and your database is. For example, in development, your product or your system is locally 1 ms far from your database, but when it's in production, it will be almost 300 ms across regions. Then you have concurrency. You tested alone in production, but here you meet 100 users. It's not the same as how you are testing in the staging method. Then we have failure modes. You never saw these failures locally, like M-Pesa timeouts and network drops, but in production is when they start to appear. And then we have observability. This is the tools you need to observe and to make sure your product is really working. So your terminal window becomes a centralized log system, which you have to set up. The key message here is code behaves differently when real users, real data, and real traffic are involved. So we have health checks. We have the first one, which is liveness. Here in health checks, there are two endpoints, which is liveness and readiness. So in liveness is the process is awake, your system is awake. There is no need for deep checks, it just exists. So if this fails, the platform should restart the whole container. This is like when someone knocks at your door and then you say, "I'm home," and you don't need to say anything, so they know there's someone inside. And then the next endpoint is readiness. Readiness are your dependencies, like the database, M-Pesa credentials. Are they reachable? If this fails, the platform should stop sending traffic, but it should not restart it. So a common mistake people may make is merging these two into one endpoint. This is bad because, For example, you have a brief database hiccup. You don't need to restart the whole thing. For a brief database hiccup, you just need to reroute the traffic until the database recovers. So you need different solutions for different problems. And the key message here is alive does not mean it's ready. So we have the health check code. Now here, I hope you can see, the first check is a liveness check. It returns the status okay if your system is live. It returns the get checks the liveness of your system, and then it returns the status okay and the timestamp, which are the dates. And then you have the second one, which is the readiness check code. This actually pings the database. If the query comes back, it will say we are ready. If it throws a return a service unavailable, so that means it's not sending traffic. So the application should know when to stop accepting requests. I'll move to the next one, which is observability and alerting. So observability is the tools you need to observe whether your system is working or not. So we have three of them, the three pillars. The first one is logs, the second one is metrics, and the third one is traces. So logs is what happens in your system. Did the user log in? Kama zetu, were the payments recorded or did they fail? Were the APIs requests made? And then you have the metrics, how much and how fast. This measures the requests per minute, the error rates, the responsive time, contributions per hour. This is more mathematical. Then next we have the traces. This is where the time went. It tracks a request through multiple services. And then we have something called personal identifiable information. This is the personal information that appears on a site. Your passwords, your APIs, your JWT tokens, M-Pesa secrets. These must never sit in a plain text logs. So you do something called reduction. Reduction is hiding this personal identifiable information. Now this, if you are here the last time, it ties back to the last session, which was hardening the build. And then we have alerting principles. When should you alert when you have an issue in your system? So you should alert on symptoms and not causes. When, for example, users can't contribute in Zetu, this deserves an alert because it's a symptom. But when something like connection pool is 80%, that doesn't need any alerts because it's a cause. Yeah, you don't need to page a human for that. Then observability without alerting is a museum exhibit. You can have beautiful dashboards for your site for how you check your operations, but if you don't have alerts, those dashboards that look good are just useless. So we have the logging and exception scopes. This is the redact block in that code. The redact, I told you, it's hiding the sensitive information like the passwords. Now here we have the login, which is the first one, which is the Pino redact filter. This produces a structured log for things like user IDs, timestamps, and request IDs, which is much more easier to research. And then there in the sensor, as you can see, the redacted, that checks all the passwords, the header authorizations, the phone numbers, and puts them inside that body so that they cannot be visible while your system is in production. And then we have the sentry target block. This is your error tracking tool. So the before send hook runs before every error reports. So this checks the errors, expectations, crashes, performance issues, and it automatically reports the errors. So even in this sentry code, you must have the redacted body, because these are two different codes. So and it's mostly used in Next.js for backend. So you must have the request header, the requests, the headers, authorizations, and the passwords hidden at all time. Then next we have the rollbacks, on call, and capacity. Now rollback is going back. So while you are in development, you should tag your releases. For example, today you released a feature in Z2, you tag it as version 1. When next week you release another one, you tag it as version 2, so that when you come to do a rollback after a failure, you might be able to go back to the previous versions and check when something goes wrong, the rollback, is it equal? Deploy the previous tags. And this is the same thing as that team that did not have a backup. They did not check their backups before they put them to practice. So you should practice your rollback before an incident. Always make sure you test your rollbacks and your backups before an incident happens in production. If the first time you run your rollback procedure is during a live outage, you might get problems and it might cause damage to your system. Then you have on call. On call is in your team of developers who responds to a failure at maybe 3 a.m. So you must document or have a list of how people should respond to these calls, and document who's first, who's second. If there is no response in 15 minutes, you must document that too, and it must rotate so that to avoid burnout for the team members. Yeah. So, and then there is capacity, sizing limits. This is the boundaries of the database, the connection pools, and external limits. How much traffic can your system handle? You should know the number of the database connection pools, the limit, the M-Pesa API rates limits, your hosting plan, and for your limits, you should always alert at maybe 70%. You should not wait for 100% so that you can start alerting your failures. By the time you are in 100%, the incident is already happened. So by alerting at maybe 80%, you have some time and to maybe save your system. Always alert before reaching the limits. So the key message here is recovery speed determines confidence in releasing softwares. We have 3 failure modes. We have the silent, which is internal failures. This is where nothing errors. You get no alerts, but the outcome is always wrong and nobody notices. So for example, in Z2, M-Pesa callbacks URL silently changes. Payments are accepted but never confirmed as paid. You catch this failure during a business metric alert. So the contributions drop maybe to 0 because the traditional monitoring ways did not display anything wrong. And then we have another failure, which is the cascading. This is when one small feature triggers another failure, like a chain reaction. Like one slow query fills up the connection pool, which then stalls all requests, which maxes out the database, which takes down everything with it. Now you'll catch this error or failure using latency and resource utilization alerts. And then the other failure is degradation. This is like your phone battery. When your phone is new, the battery will last longer, but when you use it over time, it becomes poor. So there's a single break. There's no single major break in degradation, but just a slow creep of small breakages. The latency or errors inching up over weeks and months, but you can't really notice. So this is, you can catch this using trend-based alerts and periodic dashboards, which review real-time alarms. Error rates catch cascading failures. Business metrics catch silent failures, while trend alerts catch degradation failures. And you always need all these 3 types, not just one. Then there is the maintenance. Operation is and maintenance, they go hand in hand. So to keep your system healthy, alive, ready, you need to always maintain it. It's like a vehicle. You always need to take your vehicle for an oil change, for coolant, maybe you change the coolant. Yeah. So there are 4 categories of maintenance here. There is the first one, which is corrective. This is urgent. This is when a bug in production appears, which affects users. Here you will stop what you are doing and fix it. And when you fix it, you deploy it with a regression test. Otherwise, you're making temporary repairs, not actual fix. If you do that, it will come back. Now the next one is adaptive. This is, for example, Z2. We'll use Safaricom Daraja APIs, and with time maybe they can change them, and they update the Daraja callbacks, the payload format, and this isn't your bug. You are not the one who caused this, because the updates were there and your system was using previous versions, so you didn't cause it, but you have to adapt to it, and you have to do it within a reasonable window because users are always impacted in production. Then we have perfective. This is planned. This is like when in a road you notice a small crack, which with time will turn to be a big pothole. So you come and fix it. It wasn't broken, but you just make it better. So the system works correctly, you're just making it better. There's no bugs, you just want it to be faster. Maybe over time it became slower because of things like slow contribution rates. You add things like an index, it drops, which when you update your system, it may affect other things that you are not really working on. So this may cause slow processing of your system. So this perfective maintenance will make it faster and make it better. And then we have preventive. This is the most important category here, because we know prevention is better than cure. So maybe you address an issue before they disrupt your workflows, and because when it works nothing happens, but when you detect an error or you sense there might be anything that might happen which may cause a failure to your system, you prevent it before it happens. Then we have the next one, which is scale, recovery, and compliance. And here we have stages. We have the pilot stage. For example, in Z2, we will be in a pilot stage where there will be 10 to maybe 100 users. Now in this stage you'll need things like one server, small database, minor monitoring, and then you'll need things like single node APIs, small Postgres, SQL, things like that. And then we have the next one in sizing, which is the growth stage. After shipping Z2, the users will grow obviously, and they may reach in this stage from 1,000 to maybe 110,000. And here you'll need things like load balancing, caching, and you increase the number of servers you're using, you increase your monitoring, and things will run smoothly. The other stage is scale, where now your system or your product is largely used out there. It has more than 100,000 users. So you need distributed systems. You need queues and much more servers, much more monitoring. It just grows over time. That's why you need good discipline when it comes to operation. And then you have the two clocks. These are, you have the deploy clock and the recovery clock. The deploy clock is how fast you can ship and change, and the recovery clock is how fast you can undo a bad change. The deploy clock is more of velocity, how fast, while recovery is more of risking because it's already shipped. Now your deploy speed doesn't matter if your recovery speed is slow. A 30-minute deploy with a 30-minute recovery means you can ship aggressively, while a 30-minute deploy with a 5-hour recovery means you can't. No matter how fast you can push code, because the cost of being wrong is too high. Then you have something called the ODPC, 72-hour rule or mandate in Kenya. This is a Kenyan Data Protection Act demand notifying the regulator within 72 hours of a maybe data breach. So this, when there's something like a data breach, there's when it happened and there's when you noticed it, when your team maybe became aware of it. So this is when the 72-hour rule starts to apply, not from when the breach actually happened. The clock starts the moment someone notices the failure or the breach. And without good observability, you might not notice the failure for weeks or even months, and this will cost you. No. Operations is always a compliance. It's not a separate concern from security, legal. It's the mechanism that makes compliance possible. So key operational takeaways, we have deployment, tumeongelea hiyo. This is keeping your code in the server. This is the easiest part, right before you ship. And then we have the six questions that every developer while shipping a product should ask themselves, which are health, observability, alerting, the rollbacks, on call, and capacity. You should always answer those questions. If you can't, you need some work to do. Yeah. And then you should always stay ahead of outages. You should always make sure your systems run properly while shipping. I know most of us have reached only the deployment part, but shipping is where now work begins. Yeah. So that's my talk. I'll open the ground for any questions.